Remember I said we were going to do surface tensions? What was surface tension defined as? That fancy gamma? And I said surface tension is not a force. Just like pressure is not a force. What is surface tension? We defined it as F over L.
Surface force over length along which.
There we go. So this is not a force, it is newtons per meter. Always remember that. It is the force that acts per unit length. Just like, remember, pressure is force per unit. What is surface tension? Force per unit. Okay. There is another definition for gamma, which is force per unit length. May I multiply and divide this by delta x? Anything stopping me from that? What is F dot dx? Work. Good. And what is L dot dx? What is L dot dx? Area? Can I then write this as delta U over delta A? Is work equals potential energy? Right? Work kinetic energy theorem, work potential energy, they're all related. So gamma can also be defined as surface potential energy per unit area. So remember, pressure was force per unit area. Surface tension is energy per unit area. And remember, when you have two surfaces, you have to do 2 times. So for example, if you have a soap bubble, how many surfaces does a soap bubble have? 1 and 2. 1 on the outside, like outside surface, and 1 on the inside surface. So when you have 2 surfaces, you have to do twice the surface area. Twice the surface tension. Okay, because it has to maintain both surfaces in order to exist. For most substances, it only has 1 surface area, right? Like if you have a water container, only 1 surface. But if you have a soap bubble, that's a good example of surfaces that have 2 object that has 2 surfaces. Okay, so it has to maintain both. If one of them collapses, will the soap bubble exist? It has to maintain both.